This is a second video on the 8-step problem-solving method. In particular, this video covers steps 4 through 8 of the 8-step method. I am Mark Holloway, and this video was prepared for MFS 526 Lean Operations Management at the University of Kentucky. In a previous class module, we discussed steps 1 through 3 of the 8-step problem-solving method. Recall that step 1 was where we define the overall problem as a gap between our current situation and what we expect and want to occur, either the standard or maybe a future goal. This should be a measurable gap, and the gap should relate to a large overall goal of the work area, which somehow or another should contribute to the overall goal of the company. For example, a company's high-level goal might be to produce quality parts, which gets translated down to this workstation's goal of creating quality parts. In step 2, we want to narrow the problem down, so we slice and dice the data and zoom in on different processes to try to find a subproblem which would have the biggest impact if we solve. The biggest impact could be defined as based on the frequency of the problem, the severity or urgency of the problem, cost of the problem, or perhaps a problem that will expand if we don't deal with it soon. We then go visit the processes to see firsthand where the problem seems to occur first. This is the point of occurrence, and the visiting of the process is Genchi Genbutsu. In step 3, we clearly state what our narrowed problem is, and we set a target based on the data in step 2. This target is what we expect the improvement will be if we successfully solve the problem. We can now do step 4, our root cause analysis. Here is where we finally get to explore the different possible causes of the problem, exploring these by going and seeing, and then identifying the root cause through a chain of asking why repeatedly. So we've been doing problem solving through all the prior steps 1 through 3, but we really haven't been able to ask the question as to why are we having this problem. Now we have the chance to do this. In doing this, we want to really explore all the different possibilities of why. So a good way to do this is in a structured manner, like the 4M1E possible causes listed here. So 4M1E basically stands for man, machine, material, method, and environment, and we want to explore the impact of all of these on our problem. Is the cause a person who perhaps isn't doing the work correctly, maybe because he or she hasn't been trained or doesn't understand the job? Is the cause a machine, or that maybe performs inconsistently, or is failing, or is worn, or somehow is causing? Is the cause instead maybe the material that we're working with, the parts that we are getting from the supplier? Perhaps there are variations in these parts or in the material where it doesn't consistently have the properties that we need. Under method, maybe it's the standardized work itself, so that the method is not specific enough to deliver consistently good results. Finally, we must consider the environment. Maybe we have things interfering with the workspace, or maybe the temperature, or humidity, or noise, or distractions are causing problems. Some people use the term fishbone diagram to explain the stage of the 4 M's and the E. If we write out all the possible causes we are considering and then go down further, each one of these looks kind of like a tree that grows out of a common starting point. And so these can be arranged, it actually starts looking like a fishbone, that's called fishbone diagram. In summary, though, what we really want to do is fully consider as many possible causes as possible as we want to find the real cause. Here is an example of the 4M1E breakdown. We are wanting to find out why our polished parts have blemishes. By using the 4M1E, we are able to list out possible causes. When analyzing the root cause, remember to go and see to understand what is happening. We already spoke of 4M1E, but there may be other important things to know. There's only so much that we can know from brainstorming at a distance. At some point, we have to go and see. When going and see, you can better understand how the workspace is organized, how things interact with each other, etc. We can better understand the standardized work that always being followed. We can see if the problems occur continuously or erratically, or in some pattern based on interactions of cycles or processes. For example, maybe a process does mixed models where some of the products are product A and some are product B. Perhaps the issue on product A only happens immediately following the work on product B. These are things that might not be evident from basic data that we give, but we can see these by watching the process. Also, while there, we should ask, what has changed? If problems started getting worse just a month ago, for example, we should find out if anything has changed in the last month. Maybe there was a change in fixturing, a change in personnel, a change in a parts supply. It is even possible that there was some Kaizen implemented last month that wasn't fully tested and understood for other impacts. It's important that you don't introduce any bias while you are going through seeking potential root causes. So, for example, perhaps there's a highly skilled employee and you want to assume that this employee, of course, couldn't be the cause. But even skilled employees may make mistakes or have modified the technique, or maybe if they're following the standardized work perfectly, maybe there's an issue with the standardized work. Maybe this employee has a sore arm and is doing things a little differently than his or her past technique. So it's important that we explore these things and not instantly assume that certain things are off limits. It's also easy to introduce biases through pet peeves. You might think to yourself, my gut reaction says it is the feed mechanism. I have always disliked the feed mechanism. Okay, well, it may be the feed mechanism, but we need not to assume that. We shouldn't assume that. We need to make sure we want to find a real root cause, not just picking whatever the boss suspects or you suspect might be the cause. As we brainstorm, we want to identify all the possible reasons. We will explore a lot of ideas, but at some point we need to start confirming these ideas. We want to then have informed brainstorming, where we can support our exploration with facts rather than just speculation. We want to use facts to zero in on the most likely cause. Once we have identified the likely cause, that doesn't mean we stop. That likely cause is really the start of another layer of brainstorming, informed with facts, and go and see why. In effect, we are asking why, and as we select a possible cause based on facts, we will keep asking why again, create another layer of informed brainstorming. And we will repeat this asking of why until it seems we can't go deeper. We sometimes use the expression 5 whys to emphasize this repeated exploration of causes at deeper and deeper levels. There is nothing magic about the number 5. We may only be able to go 3 deep or 7 deep, but the idea is we need to ask why again and again until we can't ask why anymore. At the bottom of this chain of whys is our root cause, which is something that we are able to address, and that there are no further whys. Here's an example of the 5 whys. The problem is that the welding robot stops in the middle of its operation. Why is it stopping? Because the fuse is broken. As you can see in this example, there's a sequence of deeper whys to finally make it to the bottom level. Why is the circuit overloaded? Because the bearings are damaged when all locked up. Why? Because there was insufficient lubrication on the bearings. Why? Because the oil pump on the robot is not circulating sufficient oil. Why? Because the pump intake is clogged with metal shavings. Why?
So
There is
that's
no
going to
filter
be
on pump
difficult
intake
for me to
as
catch
is.
on to because I don't
So
find
finally
you
we get to the
guys
root cause, that there is no filter on the pump intake, and that is the way it was designed. If we had a filter, then we could keep the pump intake from getting clogged and solve the rest of the problems by opening it up. A good sequence of cause and effect should all follow as the
Did you
causes
guys have
bound
a
the chain. And if
reservation?
it does,
Like,
therefore,
that isn't
thus if we open it up, we
improper.
find there is no filter on the pump
No,
intake.
definitely not.
Therefore, the pump intake is clogged with metal shavings. Therefore, the oil pump on the robot is not
But
circulating enough oil.
it's just a
And
learning
so forth
curve,
and so on.
but
And
they
therefore,
know
the
that,
breathing
so
result is
it's
poor.
fine.
This diagram summarizes our discussion on step 4. We start with brainstorming, go and see, get input from those close to the process, and select the most likely cause, and then we start asking why until we get to the root cause. Note that as we ask why deeper into the problem, we may need to brainstorm for a cause again and go and see. Thus, there's a loop of these steps until we get to the root cause. At the bottom of the slide are listed 2 ways we can actually present step 4 in our 8-step problem solving. One way is to show the root cause decision tree, showing what was ruled out and what was selected. The other way is to show the 5Y chain of causes down to the root cause. Here we show step 4 for our water leak example. We've gone through the process of exploring reasons for why we have the leaks in the tail light area. We determined that there are gaps in the sealant. By asking why repeatedly at each level, we determined that the standardized work is missing information on how the team member should angle the spatula to get proper coverage. This is our root cause. Note that in this process, we might have explored lots of other reasons, such as whether the sealant was defective, or whether the spatula is the right tool for applying the sealant, or whether the taillight area surface is contaminated and not allowing the sealant to bond, etc. We may explore a lot of different ideas, and in some cases, we may want to show some of the other items considered through a table listing these other 4 unknown categories. The most critical part is that we want to show the chain of cause and effect that seems to best explain the situation that we have based on our analysis, our data, and our go and see. This is shown here. You are now ready to do the case study, step 4. Please pause the video and resume it after you have done case study, step 3. We are now ready for step 5. Step 5 is where we start considering countermeasures to tackle our root cause. Step 5 involves brainstorming for possible solutions in the same way as step 4 involved brainstorming for possible causes. The first part of step 5 is to develop as many potential solutions to countermeasures as possible. We then want to narrow down our list of those solutions to those that are most practical and effective, and we need to seek input and consensus from others to do our Nemo washing. Finally, we must develop a clear and detailed action plan. Let's dive into each of the parts of step 5 in more detail. For step 5, the first thing we want to do is explore possible countermeasures, possible solutions. So this is, in many ways, a brainstorming activity where we really want to think of the different possibilities. We want to seek input from others who may have different experiences or expertise or perspectives. This especially includes the direct process workers who have the most familiarity with the process. Once we have developed possible countermeasures, we want to select the countermeasure with the highest value add. What do we mean by value add? We want to look at the benefits versus the costs for these countermeasures. This will be discussed in subsequent slides. As we look at these benefits and costs, as we do so, we want to consult with others again, those who might understand any unintended consequences or potential issues with the different proposed countermeasures. Also, it is important to see if others in the organization have tackled similar problems. It may be that our process or our machine is similar in other parts of the company, and maybe they have experience already in tackling something similar. We should be able to learn and benefit from their experience also, so we need to make sure we seek input from elsewhere. As we explore potential countermeasures, we want to find solutions that will eliminate the root cause. Just like when we were doing brainstorming in step 4, we need to make sure not to bring any prejudice or bias into our exploration. As mentioned on the previous slide, we want to determine what we can change or not, and whether countermeasures have been successfully developed elsewhere in the organization for a similar situation. Here is an example that we looked at before. A welding robot often stops in the middle of its operation. The cause we determined was because of metal shavings clogging the hydraulic pump intake because there is no filter on the pump. Thus, the root cause is that the system was designed with no filter on its pump intake and thus has no filter. What are some ways we could address this? Well, one obvious way is to modify the system to install a filter before the pump. This would include some modification of the machine and periodic maintenance to change the oil filter. However, what if we can't modify the current machine for some reason? Maybe we would need to monitor and replace the oil more regularly, like we do in a car, or maybe we periodically drain and filter the oil before replacing it. One option is to replace the machine. This sounds expensive, and there may be many reasons not to do this, but perhaps there are other reasons why it is time to consider a replacement. Another option would be to go down to the root cause chain a little differently. Up one level, when we asked why the pump intake is clogged with metal shavings, perhaps the shavings aren't just from regular wear and tear, but because some other part of the machine is approaching failure. Our countermeasure for this may be to replace the part that is wearing out. A key point here is that there are probably lots of countermeasures we could explore, and lots of different Y chains we may go to. Each countermeasure has a different pro and con. We want to make sure that we explore lots of possible reasons other than just jump to a conclusion of an answer right away. To help us in exploring possible countermeasures, sometimes it's useful to have some prompts to guide us to think in different directions. One way we could do this is by asking questions of where, when, what, and how. In this example, a root cause of a problem is that the pallet storage area is not large enough. As we consider solutions, we can use these prompts to explore different options. Now that we've identified a list of possible countermeasures, we want to evaluate these to choose the best one. There are many dimensions that may need to be evaluated. Of course, the first one to consider is whether the countermeasure would be effective. Does it eliminate the root cause? Will it get us to the target? Each countermeasure will have costs and benefits, and some of these are immediate, and some of these are longer term. Replacing or modifying a piece of equipment may have cost to it, and that might be a lot or a little. Maybe there are longer term costs, such as a modification of standardized work that adds extra steps or more personnel time. Maybe there are longer term costs to upkeep or regularly maintain the countermeasure. For every countermeasure, there are likely risks. Does this potentially impact safety or quality, or does it make the task more difficult? Does it impact the previous or the following work processes? Depending on the problem being solved, there may be many different factors to consider when evaluating potential countermeasures. The details of these depend on the solution, but the key is that we must recognize and consider the effectiveness, the cost, the manpower, and the risks of any potential solution. A matrix like this one shown here is a useful way of summarizing the factors that we're considering in evaluating countermeasures. So here in this diagram as an example, note that it has a column for effectiveness for each option. In other words, how well each countermeasure solves the problem and meets the target. It also has a column for cost and manpower. It then has a group of columns associated with risks, with each individual column in this group with a specific risk noted. The final column indicates an overall judging. In the matrix, for each option and each factor, we have a symbol to represent our evaluation. A circle indicates that the option is good for this factor. The triangle represents it is okay, but not great, and maybe there are concerns, and it's viewed as being not as good as the circle. The X indicates that the factor is not good. We will fill out all the other items in the table before doing the last column. As we fill out all these other items, we want to double check comparatively within each column and make sure the evaluation marks make sense comparing one option with another. Also, when we rate these options, we should seek input, facts, and perspectives from other people who may have different understanding of these factors. For example, maybe we need to consider safety for the ergonomic impact of suggested change, or maybe the facilities team for an understanding that will have the necessary electricity, plumbing, or structural support for some options. Or maybe we consult the maintenance team to understand how easy or difficult a machine modification may be.
They have the thank you
Finally,
card
the
right
final
there.
column. Based on the factor evaluations for all the other items, we will give an overall judgment for each of our options. We will use the same kinds of symbols to indicate good, okay with concerns, and not good. But there is an additional symbol we introduce here. The double circle will be used for the option that we are declaring as optimal or best. As we see in this example, the bottom option the bottom option in this table has the most good and okays and doesn't have any not good evaluations. So that is the one that we select as best. It is given the double circle symbol. Some companies may use a number system or a letter grade instead of these shapes. That's okay, but the shapes allow a very rapid visualization of how each of these options compare across the factors. Also, if we use numbers, we should avoid being too rigid about just selecting the highest number total as our optimal. Some of these columns may be more important than others, and we can consider that when determining the overall in the next column. I know that this table is an example of how to evaluate and choose the best. There are other ways to do this, but the key is to have a methodical way to evaluate effectiveness, cost, manpower, and risk options, and then to choose one based on these factors. A table like this helps us accomplish that selection and that evaluation and selection, and it helps us document and communicate this process. After we've done our evaluation of options and selection of the best option, it is important that we build consensus with others on the solution. Already, we should have consulted with others as we explored and evaluated our different options, but we now need to close the loop with the relevant parties and make sure that they understand what solution we've selected and how we've taken it forward. Sometimes this building consensus can be done through a group meeting of the relevant parties. Often several such meetings may take place over time to update in this process. Often such a meeting should not be to declare your solution as final, but rather to present the analysis and ideas and direction, to share your latest progress, and to seek input from others. These other parties can ask questions and provide insights and important feedback in case there are considerations that you haven't thought of in your proposed countermeasure. If all goes well, however, you will have done the analysis well enough and presented your methods well enough that the group understands and will be able to support your solution. Such a meeting of the different people helps these other relevant groups represented to start thinking about how the solution may impact their group. It helps them raise any additional issues, and it serves as an opportunity for problem-solving coaching for the person who is doing the problem solving. Another important benefit of this process, and perhaps the biggest benefit in my own personal opinion, is that such a presentation in meetings to build consensus is an important way to avoid surprises or issues or concerns popping up when final decisions are later being made. The management making decisions may want to know that these other parties have seen and understood and support your work. Although such consensus-building meetings may seem like more time and effort up front, it may help move to a better solution and should improve the likelihood of agreement and quicker approval and support later without surprises. At this point, once consensus is reached, the planning phase is complete. As a reminder, we are in step 5. So far, we've developed as many potential countermeasures as possible, we've identified the countermeasure that is most practical and effective, and we've practiced numeracy. In other words, we've briefed others and sought consensus on our plan direction. We are now ready for the last part of step 5. Here, we are ready to create a clear and detailed action plan. What are important elements of a good action plan? Such a plan should specify who, what, and when.
What the heck?
Are the what
Yes,
tasks
it will be off
to
the
implement
road.
the plan, who does each of these tasks, and when do these steps take place. But where items is a little more vague. Sometimes a task is obvious that it needs to be done in the workstation, but where could also indicate useful details about the mode of communication, like a team meeting, or where it might indicate details, or where a prototype might be built or tested. A table like this is an easy way to indicate these elements of the action plan. Each row defines what needs
If
to be
it were
done. Also,
mine,
indicates
I
who is
probably
responsible, and it
wouldn't
shows the when on a timeline.
have
This
this.
chart has many of the same characteristics as a Gantt
Yeah,
chart,
no,
but
I
maybe
would
in a
have
different
like
way.
a.
Because of the way the timeline is laid out, we can easily see how much time is dedicated to different tasks and how these tasks work in parallel.
If it were me, I wouldn't have that.
As you develop an action plan, think also about what
I would
tasks need
have a
to be done
smaller
that are consistent with
couch,
the
and I would
principles.
honestly try to fit
Are
it
there
in.
tasks for Nina Washi to debrief and seek buy-in with others? As part of the Plan, Do, Check, Act PDCA cycle, are there task items identified for testing out the countermeasures in order to evaluate them and refine them before full-scale implementation? What about updating standardized work in other documents
Big
and
bar
processes?
is kind of what
If we
takes up
keep
the
problems coming
space,
back,
because you
then
could
we
put
need
a
to make sure
table
that
over
countermeasures
that.
become part of our regular operations.
Over here, yeah.
This slide summarizes several things we've already discussed in step 5. To summarize briefly, we want to brainstorm to identify possible countermeasures, narrow these down to 3 to 6 options, and seek input from others, and then evaluate these 3 to 6 options with an evaluation matrix to help us select the one best countermeasure. We will then make an implementation plan for this countermeasure. Throughout all these steps, we will involve others, initially for getting countermeasure ideas, then regarding how we should be evaluating these, what factors to be considering, and then on how we implement them. And finally, we will involve others in terms of giving status updates to them. You are now ready to do case study step 5. Please pause your video and resume it after you have done case study step 5. Steps 1 through 5 were all a form of planning. We started with an overall problem, broke it down into subproblems, and selected the one with the most impact, and then set a target for the improvement that we want to see by addressing this prioritized subproblem.
I'm
Step 4
hungry,
was
I'm
and
excited.
step 5, we developed an action plan for addressing
You
this.
don't know.
In step 6, we are finally taking action. We will follow our action plan that we developed in step 5, and then we will share our progress with stakeholders and consult with them.
This couch
So we want
is
to knock out
so
this problem. We should work speedily as a team, most importantly, so that we can eliminate this problem from continuing, but also while we have a good understanding of the process before the situation may change or other factors may interfere. As we do this, we need to regularly report, inform, and consult with stakeholders, and we need to keep at it persistently, keep at this problem countermeasure plan persistently until the countermeasure is implemented and the problem is addressed. It should be pointed out that this implementation stage may be difficult. Even with all of our intensive planning from all the other steps, and with our prior consulting and seeking input from others, there still may be unforeseen difficulties. We must be persistent to find our way around or through these difficulties. This is also where culture really shows up. In a true lean organization, the leadership must understand that difficulties may arise, but the leadership should help the team weather through these rough spots, redirect when necessary, and help them ultimately achieve the target. Regular updates on progress are important. You shouldn't just assume a meeting in someone's office or conference room is sufficient. Ideally, the team will have regular updates close to the process so that all may go and see for better understanding and identification of how to navigate around any